All right, so we were working with solving equations that had logs in them. Some of our equations had logs, every term had a log, and some did not. We had to use our properties of logs to try to combine these things as much as possible. So if I look at the left, you have two logs subtracted. So how do you put those together? Divide. When you do that, you write the log one time, and then it's x over x plus 2. Okay. Then if there's only a log on one side, what do we do? Change it to exponential. What is the base of a natural log? E. So that means e to the 4th power equals x over x plus 2. So now if I'm going to solve this, what would I do? So we get x e to the 4th plus 2 e to the 4th equals x. We are trying to solve for x, and how many of those do we have in our problem? 2, so we need them on the same side. So I'm going to subtract that one over. Can you actually subtract those things? So what would we do instead? And so then to get x by itself, you would divide. So we have 2 e to the 4th over 1 minus e to the 4th. We were giving decimals on these. So let's go ahead and put that in our calculator. And so we get negative 2.0373. Yes.
Get that.
Okay.
I don't know why.
Did you put the denominator in parentheses?
Oh, no.
Anytime you have more than one term, make sure you put parentheses. If you want to be safe, just always do parentheses around top and bottom. I'll make sure it's taken care of. Good question. Let's just do some more. Oh wait, we aren't done, are we? What do we have to do at the end? Check our answer. Remember, the argument always has to be positive. Is it possible to plug in a negative 2 here? No. So what does that mean? No solution. At the end, when you have a log, the argument, whatever you're doing the log of, has to be positive every time. So we always have to check and make sure that when we plug those back in, we have positive arguments. All right, let's do another one. What would we need to do here? Divide. To combine these two logs, we divide. So it's log base 1/3 of x squared plus x over x squared minus x equals negative 1. Then can't multiply it yet because it's the log of that whole thing. It's inside my log. Exponential. 1/3 to the negative 1 equals x squared plus x over x squared minus 6. If we want to make life a little bit easier, what is 1/3 to the negative 1? 3. So then I can multiply by my denominator on both sides. So we get 3x squared minus 3x equals x squared plus x. And then if we set this equal to 0, we get 2x squared minus 4x equals 0. So we could take out a 2x. So we get x to be 0 and positive. Are both of those answers okay? The numbers themselves are positive, but we have to make sure when we plug them in, we're going to get positives. If I put in a 0, I get the log of 0. Can you do 1/3 to a power and get 0 for an answer? No, it has to be greater than 0. Whatever your argument is, it's always greater than 0. So that 0 does not work, but 2 does. So we only get one answer here. A few more. Every problem I've done so far today had one term without a log, so we combined the logs that we did have and then changed it to exponential. This one's different because everything has a log in it. What could we do? Combine. They're not really like terms, but on the left I have 2 logs. How would I combine those? Multiply. Properties of logs. If you have 2 logs added, you can combine them into one by multiplying their arguments. So we get the natural log of x squared minus 4x equals the natural log of x plus 6. Now in the others we changed it to exponential.
Can't you just drop the natural log?
Yes, since I have one log on each side, just like when we did those exponentials where it was like 3 to the x equals 3 to the 5th, we could drop that 3 because it was the same base. Since I have the same log on each side, I can drop those. It's a quadratic, so we have to set it equal to 0. So subtract over the x, subtract over the 6. So what numbers would multiply to negative 6 and add to negative 5? Negative 6 and a positive 1. Set those equal to 0, and we get x equals 6 and negative 1. Am I finished? No, we have to check that when I plug these in, my arguments are positive. I don't care necessarily if the x itself is positive, the argument has to be. So if I put in a 6, that's good. 6 minus 4 is good. 6 plus 6 is good. But can I put in a negative 1? No. So my only answer here is 6. So what do we need to do here? We write this log base A one time. It'll be x minus 1 divided by x plus 6. On the right, log base A of x minus 2 over x plus 3. From here, if you have a log on each side, what do we need to do? Drop the log. Then what do we do? Yeah, cross multiplying would take care of that. If I multiply those two, we have to FOIL, so we get x squared plus 3x and minus 1. This would be plus 2x minus 3 equals, would be an x squared plus 4x minus 12. If we subtract our x squared, it actually cancels. X to equal 9 over 2. Check it, 9 over 2 is like 4.5, so 4.5 minus 1 is good, 4.5 plus 6 is fine, 4.5 minus 2, 4.5 plus 3, those are all positives, so that one works. How are we doing so far? So this is where I was hoping to have gotten Friday. What we're going to do is I'm going to go ahead and give you some homework. I may not give you the rest of the class to work. I'm going to give you some time to work on it, and then we might kind of go over a few more things here, there at the end. We'll see how things are going.